All right, everyone. I think we have a quorum here, so let's get started. I'm Eric Higham, Microwave Journal, a technical editor with Microwave Journal, and I'd like to welcome you to the inaugural Executive Forum. Now, we plan on this being a recurring event, and the first one, we've managed to recruit a panel of 4 technical experts, senior level personnel at 4 of the most innovative and biggest and important companies in this RF and microwave space. They all have impressive and extensive bios, and trying to get to the questions as quickly as we can. I'm not going to read through all of them, but what I am going to do is introduce them. So on the far left, we have Brian Goldstein from Analog Devices. Next to him, we have Dr. Gandhar Bura from Qorvo. Third, we have Lucas Hansen from Keysight Technologies. And to my immediate right, we have Robert Warner from Rohde Schwarz. So as you can see, the theme of this first session is emerging technology trends. So that's a pretty wide viewfinder. So let me try to change the slides. There we go. In my mind, the opportunity to capture and the challenge to address really starts with data. Now, Cisco used to do a yearly forecast by taking measurements on the data that ran across their networks. They've stopped doing that. They've decided that's not their business. But fortunately, the data extrapolates nicely. So that's what I've done here. And you see a number of factoids on the chart. And the important takeaway, there are several. The red chart is IP. So that's network traffic, campus traffic. And you see this community perhaps focuses a bit on the wireless segment, and you see that's up by a factor of 3,100, so 3 orders of magnitude. The overall traffic is up by 2 orders of magnitude, and I'm not going to get into what a petabyte and an exabyte is. It's big. Now, so that's one takeaway. The blue line is data center traffic. So between data centers, inside data centers, and you can see that's about 5 or 6 times as large. So that really reflects everything being in the cloud these days, us buying everything from Amazon and Netflix and those folks. So lots of data. Some of that data, we have to pay attention to our defense friends. Some of that unsecured data will run over the networks, so that's included in the red line, but the secure battlefield data is not. Now, that's a low amount of data. It's not going to move the curve too much, but it's very important. So we need to consider that as what do we do with that going forward. So why is this interesting? Well, it all gets down to revenue, of course. The chart that you're seeing here is from semi.org, and in their estimation, in 2025, there will be $655 billion worth of semiconductor revenue. You see the chart shows the split of that. A lot of that is digital and perhaps not as interesting to this crowd, but there's a lot of overlap. So perhaps that gets more interesting to this crowd. If we expand that viewfinder a bit, it's been forecasted in 2028 there'll be about $1.2 trillion of procurement in consumer electronics. So a big number. Defense electronics procurement, so not defense budgets, but the amount that's actually spent buying electronics, again, should be about $800 billion in 2028. So around $2 trillion worth of procurement in 2028. Arguably 40% to 50% of that goes to semiconductors. So, slow change. So what trends are we going to be monitoring? How are we going to do that? Lots of data traffic, potentially resulting in a lot of revenue. What are we going to do? We need to enable and support the expected increase in data traffic. And that's the devices that will generate the traffic, that's the networks that will handle and support the traffic, and that's the applications that really generate that need for why do we need more data traffic. We need to make communications more reliable. On the defense side of things, that phrase congested and contested spectrum is fairly common. And it's a different situation there because that truly is life or death. However, on the commercial side, as we get more and more commercial bands, we're getting more and more interference and congestion there. So in order to increase data rates, in order to support this data traffic forecast that we saw, how do we make sure that we don't get too much interference on the commercial side? Increasingly, and I've called them nodes here, but we're starting to see the need to increase the coverage area. There's still a large portion of the Earth's population that doesn't get high-speed broadband. So how do we increase that? And we're already starting to see a tighter integration of non-terrestrial networks, satellites. We've seen a number of announcements about how phones will work with satellites for SOS kind of service. So how do we integrate those? And how do we integrate wireless and wireline broadband and networks into this overall total network that allows us to get that data moving around? And then kind of what roles will satellite, automotive vehicles are becoming a much more important test bed, if you will, for capabilities and opportunities and data generation. How does IoT play into these networks? And once we start to solve those issues, how do we deal with processing and safeguarding this data? We're going to see more edge computing, more processing. AI is a hot topic, machine learning, and how and when does quantum computing and processing start to enter into all of these things? So I have asked a number of questions here, and I haven't answered any of them, and that's what our panel is for. And so you can see the panelists, and we've got a microphone. So please, if you have a question, I'd like to make this as interactive as possible. Please feel free to come up to the microphone, and ideally you'll state your name and your affiliation, and we'll go from there. And if not, hopefully I can get the creative juices flowing. If not, I've got a big list of questions that I'll ask these folks. So please don't be bashful. So let's kick this off. And we're less than a year away from the anticipated freeze date of 3GPP Release 18 and the start of what we're going to call 5G Advanced. And that's supposed to move us closer to that original vision of 5G. So what are your companies, what are your thoughts on this? What are your insights relative to that? And what are your respective companies doing to support this? And perhaps if we can start with the test and measurement folks. So Lucas, if you wouldn't mind.
All right, I'll start it out. And I always believe in setting expectations, okay? In 2011, I got my first WiMAX hotspot. And I said, how could WiMAX ever fail? This is fantastic. And so I'm just trying to level set because, you know, we're about predicting the future here. I'm sure my panelists have a better track record than me. But I'll start by saying at the end of 2011, LTE had started to be deployed, and Verizon was leading the pack, and your average data rates were 5 megabit. That's what the user was seeing. Fast forward 4 years, at the end of 2015, the average user in the United States was just getting 9.9 megabit. So the data, we just saw a lot of IP data, it was not there yet. Today, 5G has been in motion for about 4 years, same amount of time. And I did a test walking into the hall, and I got almost 200 megabit on my phone walking amongst all these people, right? So the data ramp is real, and moving forward to 2018, it's going to expand beyond just enabling more data, right? We're going to see new applications, new use cases. The RedCap, the reduced capability, is going to really take off. We're seeing a lot of pull by the operators in this space. And NTN, which I know we talked about briefly here and mentioned, is the next hot space. As we look into space and we look for these non-terrestrial networks, there's a lot of focus there to increase the capacity and get that IP data to more users. So I think we got a lot of room here for the 3GPP to drive the standards and bring together many of these use cases so that we can all have that experience going from 9.9 megabit to 200 in an environment like this.
Great, thank you.
So with the release 18 of 5G, we expect that this is a great thing for us as a technology company. With release 18, new things will come up, and maybe I think 5G will come up with the properties that were in the original versions of 5G, which are not available at the moment. So 5G will push forward into the direction what we may call 5G Advanced. And this is a great thing, and we will also get a higher coverage. We will cover additional frequency bands. We will also cover new applications like non-terrestrial networks, and we will enable a larger coverage over the world where, as you said, for some regions where no wireless network is available, and this is also done with non-terrestrial networks. So we are pretty excited about this, and we are looking forward for new challenges.
I'm going to build on my German friend's point here about how the new challenges that we're going to face collectively as an industry is around, as more and more bands in 5G and Release 18 go forward, the 3GPP has announced 80,000 band combinations, okay? The testing of 80,000 band combinations, the challenges to the RF front ends that Qorvo and ADI are working on, and many of you in this room are going to be real challenges. And what Keysight's doing is focusing on solutions that can scale non-linearly, right? You can't just add another source or another analyzer to that portfolio, but you need new and innovative measurement techniques to change the fundamentals of how you're going to test, whether it's these new bands, these new frequencies, or the combination of those working together is something that we're pioneering and working to help drive the industry forward with many of our partners.
Maybe I could
Stick it in your...
stick it in my mouth. There we go. To take what they've been saying from a test equipment side and take it to the technology side, where we've gone from 4G to 5G has taken our semiconductor technologies into more and more advanced nodes. As we've increased the bandwidth, we've improved the efficiency. We've seen ourselves go from 65 nanometer silicon to 28 nanometer to 16. So now we're in 16 nanometer at 5G. And now we see ourselves, as we go into the 5G advanced and go into 6G, we're having to move from 16 nanometer to 5 nanometer nodes. And what's really interesting is that to be able to test these products, you have to also develop the technologies that go inside of the test solutions, as well as the products themselves. So they go hand in hand. This is a very interesting ecosystem that we're talking about, but it also enables other markets. So it enables the instrumentation technology, but it also advances the aerospace and defense and the satellite technologies, because again, these markets may have smaller volumes, but they are able to leap on the volumes of the comms market and be able to take advantage of these technology developments with the right hooks and be able to take these advanced capabilities and bring them into other applications, whether it be comms, MILCOM, or beyond that into radar and EW, which are basically just comm systems as well.
So I'm going to build on that, but my colleagues at Qorvo will laugh at this. I'm going to speak out of both sides out of my mouth. Okay, side one says, from a technology perspective, it's great. We got all sorts of new combinations, new technologies. For an RF vendor like us, or for my colleagues at ADI, this is a great opportunity. You know, he talked about sub-nanometer CMOS. Likewise, we have many, many opportunities from a 3.5 space perspective to do a lot of technology advancement. Now, that's one side of my mouth talking. The other side of my mouth says, where's the money? And we don't know yet. And this is the cautious part of me, because 5G, the monetization of 5G by our customers' customers, is still, to be frank, somewhat somewhat underwhelming so far, and that's not a secret. And so, therefore, the challenge all of us have is what do we do to, in the technology space, and yet have it be monetizable by the commercial carriers, et cetera. Now, having said that, the dual use facet Brian indicated is very, very true. The DoD has been very adamant about making sure the technologies that are being built up do have a dual use function. And we, from a Qorvo standpoint, definitely agree with it because, whether it is on the defense space or on the commercial space, we actually leverage and synergize both of those, hopefully very well. But so, summary, there's lots of opportunities, lots of interesting technical challenges for us to solve, but it's the commercial side of it that makes me somewhat a bit more cautious about it.
Yeah, great, thank you. Great answers. As an anecdotal input, right around the time that Lucas was looking for his WiMAX hotspot, I was at a conference with the CTO of the big operator at the time that was pushing WiMAX, and he showed us a slide of his brand new Aston Martin DB7, and he said, WiMAX has been good to me. Now, so it wasn't so good to Lucas, but it was good to him, and I wonder whether he still has that Aston Martin. I wonder whether he still has his job. So this was mentioned in the answer, and so let's expand on this a little bit. But millimeter wave frequency ranges and massive MIMO antennas have always been part of the 5G vision. So where do we stand with things like transceiver architectures, RF front-end semiconductor technologies, and the number of array radiators? Millimeter deployment has been slower than hoped for. How much of that is attributable to architectures and technologies?
I don't think it is. I think it's attributable to show me the use case for it. I think, in my opinion, that's the biggest stumbling block. And frankly, if FR3 comes along with wider bandwidths, let's say, it is easily conceivable that millimeter wave from a 5G millimeter wave perspective, I'm not talking about phased arrays and things like that, could potentially get pushed even further right, time frame wise. I don't think that's got anything to do with readiness of the technologies. I don't think it's got anything to do with whether or not at a architecture level it is efficient or not. I mean, one could argue, hey, do you get enough coverage across a certain distance or not? Those are, if not solved, can be solved problems. But I don't know. I mean, it would be interesting to take a poll in this audience. Maybe we'll just play that game a little bit. What can you do with the extra throughput that you cannot do today? That's a question I'd like to ask. And I don't know what the answer to that is. And I'm willing to bet 90% of you don't know either. Not because all of us are not intelligent, it's just that there's probably not.
Yeah, no, I'll tell you, from our perspective, we have invested in both the sub-gigahertz, 6 gigahertz, as well as the millimeter wave. And we have definitely seen that the majority of the hardware that is being built is sub-6 gigahertz. It's easier, it's cheaper, it's a single chip solution. It's basically a single chip radio. On the millimeter wave side, you've got the phased array antenna. You've got integrated packaging, advanced packaging. And so exactly like you said, I think it is an economic decision, and we're going to see that in 6G. I suspect we'll talk about millimeter wave and terahertz and high frequency things, and it all comes down to dollars and cents. And the fact is, the lower frequency technology, being on pure silicon as opposed to going to gallium arsenide or 3.5, is going to be inherently higher integration. And so staying at the lower frequencies for as long as possible is probably what's going to happen until that bandwidth is needed.
And if I may, just to add to that point, I want to reemphasize, this is predominantly towards the commercial millimeter wave. Our friends in the Defense Department and various customers, there's a lot of buzz going around on phased arrays and such. So it's really, to reemphasize the earlier point I think both of us are making, it's not a technology issue. It's as much a use case issue.
So actually I agree that this might be also a commercial problem that the microwave technology that has developed a lot with 5G, and we have seen also benefits in other fields from the development of RF components or microwave components up to, let's say, 50 gigahertz in other fields. They got more cheaper. So, but on the other hand, microwave is still more expensive than FR1. And I think the installed base or the cost for the installed base will rise with microwaves. And even you don't have the, all the vendors, all the base station or the like telecom and etc. They need a good coverage for the whole network, and this is done by lower frequencies. Yesterday I was at the airport and I didn't have any connection to 5G or 4G, and so they are still working to get a good coverage all over the world. And maybe it takes us some time until we are ready for the microwaves. On the other hand, yes, we need also a good coverage, and maybe this is a role where we can achieve with NTN networks.
Yeah, I think that's an excellent point. I mean, this is a technical conference, so that tends to be, I think, the focus. And you folks have all done a great job of solving the technical challenges. But I bet any C-suite executives in the audience are nodding their heads up and down at the mention of business case. And if there were operators in the audience, I bet they would be kind of clapping and saying, yeah, you know, if it doesn't make sense from a business standpoint, it won't get done. So if we switch gears a little bit, but kind of related still, and I mentioned this in the intro, what are your thoughts on the SATCOM market? That segment has done a great job of reinventing itself and refocusing itself. Where do you see the opportunities, and what are the biggest challenges?
All right, so I knew it was coming, so I got the first crack at this question. So, quick side topic. I want to know who wants to go to space. If you got the free ticket, if Elon brought it to you, who's going to space? All right.
Yeah.
Okay, I'm going. So, any of you that I'm connected with on LinkedIn have seen two topics for my postings in the last couple of weeks. It's come see me at IMS, thank you, and NTN is going to be hot. So those are the fun things right now for me and for some of my excitement looking forward. The commercial deployment of non-terrestrial networks, and then I'll defer to my friends down here for the aerospace defense SATCOM, is really heating up based on the hard work the whole SAT industry has done for many years to make this technology possible, plus a few key inflection points, right? So we've seen the stats, right? Launch costs are down 90%, and 3GPP is coming in to standardize these LEO networks that can and will be deployed. And so folks like Starlink are leading the way, and they're getting that the IP technology down to the terminal. But the next frontier is getting that all the way to your handset. And I believe and I know that the physics to speak to that LEO or even GEO satellite down to your handset is real. And our front-end folks are working really hard to make that even better and improved. But going forward, there is a tremendous amount of inflection as the commercial satellite space goes from a broadcast business model to a telecommunications and data services model. And right now, I've heard the stat that 1% of the IP traffic in the world touches the satellite network. And that's going to explode as Viasat and as Starlink are launching terabits of data capacity that are going to connect us all. And I think that it's going to be an opportunity for innovation for all of us in the room, us up here included. And Keysight's looking at it from a combination of how you're going to have a combination of the satellite network and the terrestrial network working together, defined by 3GPP starting in release 17, which there is a live 3GPP release 17 satellite network available, and moving forward into release 18 and release 19 to bring all these networks together and have global coverage by multiple operators working together to provide a service to us all.
No, I'll say the space opportunity right now is unlike it's ever been before. It's so exciting because of the one, the quantity of electronics that's being launched into outer space. It makes it very exciting as a business opportunity. But the fact that we're going into LEO with these volumes, LEO has really enabled, advanced semiconductor technologies to go to space that never could before because of the reduced radiation requirements at LEO compared to MEO and GEO. And so a lot of our advanced nodes, a lot of our latest and greatest semiconductors are now able to go into space. And so we're able to take advantage of the work that we're doing in the comms market, in the automotive market, and we no longer have to develop these custom radiation hardened products. We can now take these advanced products and take them to space. And so we're able to dramatically improve capabilities and performance. We're able to dramatically reduce power consumption, which allows us to put more stuff up in space, which allows us to really amplify the bandwidth that we're able to cover. And so there's a lot of work going on to understand what are the specs that are required. Some folks are starting to really demonstrate that some radical ideas are good enough. And this concept of good enough in space is a game changer.
So I agree. I was going to comment on this entire market as Wild Wild West. And I think Brian said it in a slightly different way, but more or less to the same summary. Let me just divert a little bit for a moment. As a hobby, I do a lot of photography. And there is nothing worse for my hobby than a bunch of satellites up in the sky. It screws up astrophotography. But that's besides the point. Having said that, now, even though it's a wild, wild west, I do agree with Brian's point. The ones that will succeed, both technically and hopefully commercially, would be companies like my friends next to me or ours, where we've had a lot of pedigree in developing defense-related products that have a certain level of expectation on reliability, that have a certain level of expectation in quality, and so forth. So basically, the way I'd like to talk about space and the satellites is bringing defense kind of reliability criteria into a consumer level volume and mass production, which is really a convergence that we have never seen until now before, and it's pretty exciting, to be honest with you. Okay?
Yes, maybe I can add in a similar direction a comment. So in maybe 10, 20 years ago, space qualification was always a big topic. Only specific parts can be used in space. And nowadays, standard semiconductors are often used in space. The tubes are not that dominant in space anymore. The semiconductors improve, and with new technologies, front-end architectures, it is possible to design much cheaper satellites. And overall, I think satellite market is more and more commercializing, and the price is more and more a dominant factor. So in addition, I see an alignment between architectures and techniques that are used in 5G technology on terrestrial networks and in any satellite technology. So phased arrays, which were in earlier times used for radars on ground, were used on satellites, were used now on 5G networks, are now used also again in satellite communication. So it's a back and forth transition of technologies, and it will help to improve the technologies further and further. But unfortunately, this means that you will see more satellites on the sky in future.
Yeah, and I want to go back to Lucas's point, because I think the thing that's enabled this is the dramatic reduction in the cost of taking a satellite into space. This has allowed companies to get radical and to experiment and prove out concepts, which now the folks on the military side and NASA are starting to look and said, hey, now we've got data. SpaceX has put stuff up there. They've showed us that this stuff works. And so now people's minds are really cranking in a different way.
Yeah, I think the panelists have brought up some excellent points, and I posed the question yesterday to someone, are you concerned about saturation? There are only so many orbital slots and only so many places in the world that need to be covered. And after I got my ears boxed a little bit, the answer, of course, is no. Because with the quantity so weighted towards LEOs, LEOs have a limited life. They're not forever. And so high quantity, lots of technology, phased arrays, all that sort of stuff, and you're going to step and repeat every 5, 6, 7 years with these giant LEO constellations.
No, and that's a very good point, is that, we used to put up a geosatellite. It stayed up there to
Right.
15 to 30 years. Frankly, they stayed up there too long. There was no repeat business. Now, with these LEOs going up constantly, there's a constant technology refresh that's happening. If you talk to the folks that are launching these things, it's happening almost monthly, that they're putting up latest and greatest technologies, even as part of the same constellation.
Yeah, and I think that's critical. I was asking a sat maker, hey, are you going to deploy 3GPP? Is that something you're going to deploy? He said, no, not at first, but in a couple of years that one will burn up and I'll be able to put another one up, and maybe then I put my 3GPP forward. So these networks are going to evolve rapidly, and with this 5-year life cycle, there is a lot of innovation, and you're not locked in today.
Also, the kind of rad hard nature that these parts would need in LEO is very different than what a geosatellite would need, and that makes it a little bit more conducive for, I would call it, consumer level volume production. So that's another important.
Yeah, thank you. So have we spurred any questions from the audience? No one's brave enough to stand behind the microphone just yet, because I can go all day here. And until we get that first question, let's expand a little bit on a topic that's already been mentioned, and I mentioned it in my intro. We've seen several announcements about integrating terrestrial mobile phones into satellite networks, and it was just mentioned. What are your thoughts about that, and how will non-terrestrial networks fit into the broader wireless network? What are the opportunities that you're supporting?
So from our side, we're already starting to see this happen. The issue is that right now is that it's at low frequency. So these arrays, the satellite arrays, are enormous. Certainly it's not perfect yet, but it's coming, and there's a need for it, because how will we ultimately get bandwidth to every inch of the earth over time, and clearly to be able to do it from satellite is ideal. And the idea of being able to do it directly to my cell phone, of course, that's Shangri-La. So a lot of people are talking about it. The technologies that we're working on already for LEO, they all apply. So the basic technologies, the transceivers, the RF signal chains, technology-wise, it's there. It's more of an architectural and a money conversation more than it is, again, like we said here, it's not a technology problem.
Yeah, I agree. And, if anybody bothered to look at a Qorvo earnings statement the last quarter, it publicly says we've supported NTNs in a handset with various of our existing technologies. So that, to the point, it's not a technology issue, right? The use cases are still very nascent. We need to figure out if all I can do is send I don't know how many of you, or some of us, are old enough to remember those old Nokia candy bar phones where you could only send 15-character text message or something of that sort. The NTNs today are in that kind of a general health, right? So in order for us to have a much more data-centric approach, some of the power classes need to potentially go up. Some of the use cases and architectures need to be matured. And then one thing I'll say that Brian perhaps did not allude to is, how do you get the same level of universality through satellite communication when person X goes from country A to country B and so on and so forth? So that level of some, call it standardization, call it harmonization, whatever it is, I think that over time, I'm sure that'll happen, but it just needs to happen.
Yeah, and to his point, let's not forget, frequency is still king, right? There's a lot of frequency considerations as we go to space. There are bodies riddled all over that were threatening to, interfere with the GPS signals in the past, and are not here any longer. So I think we're going to have to see a lot of frequency policy get settled out. We're going to have to see how these global frequencies are going to play out as you're launching these networks. And if I would say watch one space to see how space is going to mature, watch where the frequency is going, because I think it's going to set the tone for all of us to make this really become a reality.
Yes, absolutely. So the standardization here is a great topic, and one point I want to add is that it's also important to get some standardization for a handover then, that if you are connected to a 5G network and you drive with your car in a decent region, urban region where no network is, that the handover works to this NTN network. This would be a topic. But maybe in the near future, especially IoT devices are very important for these networks. And I think if you have stationary IoT devices like metro station, weather stations, where you want to get some data in the desert or wherever, maybe in the Arctic, there it's also important to have this technology available.
So, just one added point to that. I think today, NTN, whether it is in 5G Advanced or early 5G, REL 17, it's coming across as a bit of an add-on. I don't want to call it a Band-Aid because that's a strong word. It's an add-on. Maybe down the road in whatever 6G happens to be, whatever REL 20 happens to be, we can take a guess. It's much more of an integrated solution rather than something that just came on a little bit later.
Yeah, it's going to be native from the onset, no doubt. It's a completely native from the beginning. REL 21, I think, but we'll see. And when you're going to see these 6G networks deployed by the end of the decade here, they're absolutely going to launch with satellite and terrestrial native from the beginning.
Yeah, great, thank you. Well, so the dam has been broken, and we've talked about 6G, and I get my IMS badge revoked if I don't talk about 6G. So if we subscribe to that notion, that seems to be true, that activities in successive generations of wireless networks are spaced by roughly 10 years. 6G deployments could be within the next 5 years. What are your thoughts on 6G in addition to what you just said? And what's that 6G path going to look like? What are your companies doing to support and enable the transition to 6G?
So dual use is, first of all, let me crack a somewhat facetious. Some of you that live in the Bay Area, like I do, you probably have seen Comcast. This is completely a joke. Comcast advertised 10G. Obviously they mean the G meaning something else, but I've always found that to be somewhat funny, right? Anyway, but on a serious note, the dual-use technologies that the government is talking about, whether it is funding chiplet integration, whether it is funding some of the work that us and other companies are doing in more and more advanced node gallium nitride devices, all of these are also relevant from our technology perspective towards what a potential 6G may be. And what Lucas said is correct, REL 21. I think the earliest date I've seen projected for REL 21 release is 28 or something like that, right? And so there's still a lot of uncertainty in what it is. Now, let me then turn it also back to the comment we had about 5G millimeter wave. My gut feel says everybody, for commercial reasons, will end up figuring out whatever the heck 6G ends up being at frequencies that are commercially viable. And then comes all of this terahertz and various other much more higher frequencies with applications to be determined. But technology-wise, I think there's a lot of work already going on, whether it is our company or theirs, I'm sure, to be prepared for these kind of activities.
Yeah. So we see a lot of trends coming up right now, like artificial intelligence, machine learning, and there are also different additional topics like joint communication and sensoring. And all these technologies will need further data rates. I think you have shown in the beginning that the data rates in the overall world will increase and increase. And with 6G, we can achieve much higher data rates. Maybe it's a matter of time when this time is coming, where we need these high data rates. Maybe if everybody has some lives in not in the real world, but in an artificial world. My kids always look on the phone, and they don't look on the world. When we were on holiday, they didn't look for the mountains or for the sea. They just took a look into their smartphone. And unfortunately, this is a trend. But we as technology specialists, we need to, or we can, if we would like to make business, we can support this trend, and we can gain from this trend. And with these new applications, data rates will increase. And if we want to have these high bandwidths, then we need to go to higher frequencies. But I know the higher frequencies cost more investment on one hand, and on the other hand, maybe also more power consumption in the end. But there are also advantages from the high frequencies. One is that with very high frequencies, all the geometries get much, much smaller. And if you integrate your antenna on a smartphone at higher frequencies, you can have antennas with higher antenna gains on the same size. And this way, the power consumption in the end can be reduced. And when in the beginning I said something about joint communication and sensing. So if we use high frequencies combined with high bandwidths, we can use the communication signal not only for communication but also for sensing. So if we use maybe some part of the bandwidth or of the signal or of the waveform, let's say, for sensing applications with some reference points, like in a radar signal, then we can detect exactly the position of the mobile. And if people just look on their mobile and walk through the city, as you can see it everywhere in any city in the world, and they walk around the corner and there's a car passing by, and if this car has some artificial intelligence and is connected with the network that knows the position of this blind people or blind kid or whatever who does not look for the traffic, then maybe it can reduce velocity and save lives this way. And this way, I think it would be really advantage to go for this technology.
I want to go on the record and said we made it 45 minutes before ML and AI was mentioned. Thank you very much. I think, you mentioned FR3 before, so I'm going to maybe just camp on that for a second. Is this 12, 13 gigahertz range going to be the next Goldilocks? It's smaller,
No,
half
it will
wavelength?
be above 100 gigahertz,
Above?
I think.
No, I don't know about that. I'm thinking that there's going to be a lot of research. Keysight started our 6G office in 2019. Today we have dozens of partnerships around the world progressing 6G already. And we're still not going to commercialize 6G until the end of, the industry is not going to commercialize until the end of 2030, right? So we got a long way to go. We got a lot of good speculation and fun to have. But my bet's on that 13 gigahertz range. I think you're going to see digital beamforming take over, and you're going to have these arrays that are drop-in replacements for the sub-6 that we have today, and you're going to unlock some real commercial use cases. What do you think?
I tend to agree. FR3 is getting a lot of traction in terms of fight between DoD guys and the commercial guys. I'm sure they'll all figure it out, and a bunch of lawyers will get paid and all of that stuff. Having said that, so in a way I concur with your opinion. But from the kind of use cases that you were mentioning, those use cases I concur with you, they do need the above, let's call it D-band type of frequencies to be had. Now, how soon they would be inside of a handset for doing something useful, my bet is I'll probably be retired by then.
Me not.
So I'll concur. So we've been our electronics have been in 6G demos already, and again building off of the work that we've done in 5G as well as some of the work that we've done on the military side, bringing the technologies together. We've been there, and it's not the terahertz. It's in the 5 to 20 gigahertz range. But again, from our perspective, we need to at least be thinking about both places. We need to be enabling the test equipment companies with the electronics that they need to be able to cover these spectrums, because even if people are dabbling at the universities, the test equipment guys need to be there providing them their equipment so that they can dabble. We need to be able to provide the electronics for them to make those test equipment. That being said, again, just like 5G, economically, 5 to 20 is going to be economically more viable than going up above 100 gigahertz and being on a process that just doesn't have the volume that being down in the lower microwave frequencies does. The other thing that's interesting for my friend here and myself is that going back to the 5 to 20 gigahertz, now your power amplifier, it's not a FET, it's probably a gas or a GaN mimic. So that's an interesting business proposition as opposed to selling these small FETs. And so there's going to be more gas and GaN in these systems more than just the silicon software-defined radio. Like
I assure you, my commentary had nothing to do with that from that perspective.
I'm here to help.
No, but seriously, you're right. But to just go back on that note, just to go back to the 100-ish gigahertz, whatever we want to call that thing, it's not like companies like ours, and I can't speak for ADI, but, I'll let Brian speak for it. Even with the government itself, I alluded to, let me make a plug to what the government calls the Starry Night program. And the Starry Night program is effectively GaN for higher frequencies than, let's say, W and E bands, okay? Now, it's quite easy to draw a trajectory from there towards the D bands and so forth. So there is work, whether it is through government-funded means or internally funded means at corporations, to develop these technologies, to develop the necessary heterogeneous integration associated with these technologies. So all of these are going on. So.
Yeah, great, thank you. So let's switch gears a bit, and let's pay our respects to, I'll get to you in 1 second. Let's pay our respects to the defense industry, which kind of arguably birthed the RF and microwave community. The U.S. administration recently submitted the 2024 DoD budget request, $842 billion. That's up by $100 billion from FY 2022, and that number doesn't include funding going to the Ukraine. So big increase in the market that typically sees about 2 to 4% yearly increase. CIPRI, that organization, reported total defense expenditures exceeding $2.2 trillion in 2022. So lots of money being spent in the defense sector. Where are you seeing the opportunities? What areas have you most excited?
Yeah, so I'll go first. So for us, right now what's really driving our growth is in the area of RF applications like radar, MILCOM, EW, satellite, airborne, ground-based. And it's about, for us, it's about taking all those trends that we just talked about in 5G and 6G and bring those technologies over to the aerospace and defense industry and really give them access to some real high performance nodes that are going to allow us to dramatically shrink down the size. We're looking for this proliferation of sensors and being able to drive down the size, weight, and power. And what's really interesting for me is that a lot of the trends of aerospace and defense are now overlapping what we're doing in communications as well as our automotive businesses in terms of converter bandwidths, in terms of power efficiency, in terms of packaging requirements, advanced chiplets, and the idea of being able to get to market faster, to be able to mix and match semiconductor nodes, bringing together the 5 nanometers and the gallium arsenides, the gallium nitrides, the silicon on insulators, and being able to have the chiplets and the digital interfaces that are required to create this ecosystem, which has really been driven very strongly by the aerospace and defense industry. But I can tell you, for it to really be adopted and see catalogs full of these chiplets, it really needs to be adopted by the comms in the automotive markets, and that's starting to happen. And so again, aerospace and defense leads the way with their investments in their performance-based challenges. And so again, it's being able to drive down the size and get the performance levels so that we can have this proliferation of communications and sensors, so that the soldier in the field has as much access to data as anybody else does, talking on a 5G phone.
Yeah. So I completely agree, and I'll say it in a different way. What the military and the defense establishment is looking for more and more, even with these heavier budgets, is A, modernization, which is great. B, this is equally important, swap seat. And that is not a term that we've heard out of the military before.
Yeah.
So some of you may be familiar with the whole concept of 5G.mil. And 5G.mil has been emphasizing O-RAN compliance or something along those lines. Why? I mean, this goes directly to Brian's point. We are definitely seeing that synergy and the dual use, as they keep calling it, between commercial use cases and defense establishment use cases. And I think that's great. That's great for companies like ADI. That's great for companies like us, because it allows us to bring economy of scale that we know how to bring, whether it is in manufacturing, whether it is in process technologies, and adapt it towards the betterment of both defense and consumer use cases. I think, therefore, it's
Yeah. So actually, I can agree. We see that, as I previously mentioned, that technologies from 5G and aerospace and also from defense merge more and more. And we, as a measurement company, we see that the same instruments, the same measurement technology is used or needed for these applications. Yeah. You want to go ahead?
Yeah, and I'll just add the idea of the intelligent edge, right? This concept of sensing, taking the data, processing the data, and making decisions right at the node, right at the sensor node, is driving our developments. And so that's true in the commercial world, and it's even more true on the defense side, where that information needs to be acted on very, very quickly. And there's a lot of data that's being collected. And to be able to send that data back to the cloud or to some central processor, that amount of data, it's impossible to send now. It takes too long. And so this idea, and I just wanted to give, for those of you who don't know much about these semiconductors, I want to give you a little bit of framework. We're talking about millions of transistors on a chip. We're talking about investments that can be anywhere from $50 to $100 million a chip per chip. And now what's interesting is as we go from 16 to 5 nanometer, the amount of digital processing on our chips is probably about 60 to 75% of the area on the chip. And so the analog section is step and repeatable. And so how do we get this advantage of taking advantage of this scale and being able to step and repeat far more quickly? And again, these designs may take 2-3 years. So how do you take advantage of the work that's been done? And this is what the concept of chiplets and advanced packaging is about, is how can you take these basic building blocks and mix and match them so that you're not doing a $100 million 3-year development project every time you go from 5G to 6G, every time you go from an X-band radar to a Ka-band radar. And so that it's this economy of scale that overlaps again between automotive, aerospace and defense, and instrumentation and communications that's going to enable us to be releasing these more expensive technologies and putting the right cost point at the right function.
Yeah, thank you. Yes, sir.
So this is more pertaining to the previous topic that we were discussing about the future of communication. So while we are quite excited about flooding the airwaves, I would just like to make a case for passive remote sensing, which oftentimes gets drowned out by a lot of active signals in and around atmosphere. And passive remote sensing is pretty much is one of the best ways that we currently have of studying weather and climate via satellites, both in LEO and GEO at specific channels, water vapor absorption lines and oxygen absorption lines. And they do suffer due to stray signals, communication signals, other systems which are using the airspace also. So while we are thinking about the future of where comms can go and high data rates, etc., I think it does behoove us a little bit to keep in mind that there are certain bands and certain frequency spectrums that need to be preserved for an extremely essential function that is performed at specific bands. But I will say that especially companies like ADI have really made it extremely convenient for us to send very cheap hardware into space, to prototype very quickly, to be able to not worry too much about radiation hardening, etc., because the hardware is so cheap and we can use and throw to a large extent. So I am very appreciative of that.
That's great. Can we use the word affordable instead of cheap?
Sure. Yeah.
Good value?
That's what I meant. Yeah.
And,
Fair enough. Thank you.
and I think on that note, we'll close this. So I would like to thank our panelists. I think they've given us a great view at the seedlings that'll be popping up, if you will, in the future. Some of the trends that we all need to keep our eyes on. And please join me in a round of applause for our panelists. Thank you very much. And a round of applause for yourselves for taking time out of what I'm sure is a busy schedule to join us. And again, as I mentioned, keep an eye on upcoming executive forums, and thanks for your attendance.